From the very beginning of the space program, NASA has been recording much of its progress through the lens of photographer Bill Taube. Taube was able to capture the essence of the space program in his work. From the time NASA began in 1958 through the last Apollo flight in 1975, he photographed every significant aeronautics and space event. Bill likes to joke that he was a photographer for NASA even before the agency was formed. In the 1940s and 50s, he worked as a wind tunnel photographer with the National Advisory Committee for Aeronautics, NACA, in Langley, Virginia. After hours, Bill worked alone, setting up his bulky 8x10 camera in the cavernous tunnels. This pioneering work let the public see aeronautical research as never before. According to Bill, his first shots were just basic wind tunnel photographs, but he always tried to think of ways to make them more artistic. In 1958, the NACA became NASA, and Bill Taube was sent to Washington, D.C. as the agency's senior photographer. He was assigned to the original 7 astronauts, covering all aspects of their lives, not just their work. Bill captured the tension of the training exercises, the camaraderie, and the spirit of each occasion. He was also the only photographer allowed free access to closed-door meetings, training runs, and missions. John Glenn made history the day he entered his Mercury capsule. Taube knew he had to provide coverage that would satisfy photo editors all over the world. And he did. During his career, he received many awards, among them Photograph of the Year for coverage of Gordon Cooper's flight in 1963. In 1969, the world watched as astronauts Armstrong, Aldrin and Collins carried out America's first mission to the moon. They became instant celebrities. After their return, they visited 24 countries and 27 cities in 45 days. For Bill, covering this world tour was a special highlight. Bill grew up in an era where travel by rail was everything, and landing on the moon was only a wild dream. While he's not tinkering with his train collection, Bill enjoys leafing through some very special books. Each page a memory, a glimpse of history in NASA's photo album, which he helped to create. This 11-ton satellite, called the Long Duration Exposure Facility, or LDEF, had been in space for almost 6 years before it was returned to Earth for examination. After delivery to the Kennedy Space Center and several months of close inspection, its 57 external experiments were shipped to scientists around the globe. The effects of long-term exposure to space can be seen in this materials and coating experiment. The various colorations and striping evident on the surface here were not present when LDEF was put into orbit. In fact, the top of this panel looked exactly like its unexposed underside prior to the journey. The goal is to determine the significance of these changes so that future spacecraft and structures can be built with the best possible materials. 22 aluminium panels were positioned around LDEF. Their mission was simple: be struck by micrometeoroids and other man-made debris. Determining how many particles are out there, where they are, and what they're made of is critical in designing future protection for astronauts in spacecraft. Research scientists discovered that a thermal control paint used almost universally on spacecraft could contaminate optical materials. This unexpected brown staining would almost certainly result in a change in surface coatings for future space applications. Learning more about cosmic rays was the goal of an LDEF experiment at the Naval Research Lab in Washington, D.C. Cosmic rays are fast-moving particles that can penetrate human skin and even disrupt onboard computers, another factor to be considered in developing future space hardware. More than 12 million tomato seeds were also carried on LDEF. They were distributed to students of all ages around the US. The majority of the plants eventually produced normal fruit. In addition to providing valuable information about the effects of space on living matter, the SEEDS project was designed to excite young people about science. The long-duration exposure facility further extended our knowledge and capabilities in space. Despite the loss of the shuttle Columbia, NASA is pressing ahead with its Mars rover project. 2 rovers were launched in one of the agency's most ambitious undertakings. The cost for the rovers, the launch, and the analysis of the information they gather is about $800 million. NASA believes the information gathered by the rovers will enhance our knowledge of the red planet and of Earth. NASA built 2 rovers to explore the surface of Mars, and they were launched separately around Delta rockets. The launches took place in 2003 for arrival in January of 2004. With 2 rovers, NASA hopes it can increase the amount of information it can gather while being prepared if one of the rovers is damaged or destroyed. It can take more than 20 minutes to get a radio message to the rovers once they have reached Mars. As a result, NASA has built the rovers to operate as independently as possible. The planned period for the rover's operation on Mars is about 90 days. However, if the rovers can avoid damage, that period might be extended to 6 months. Beyond that, the Martian winter sets in, limiting the sunlight that powers the rover's solar panels. Each rover is outfitted with all the tools a human geologist might carry into the field. The rovers will be able to pick up and scan Martian rocks. Each rover is also equipped with cameras that can transmit pictures back to Earth. These pictures will allow scientists to plan missions for the rovers. Meanwhile, NASA is still reeling from the destruction of the shuttle Columbia. Many scientists at JPL feel the Mars rover project is their way of honoring the Columbia crew's sacrifice. This is a computer-generated animation of Venus. The flight begins over Artemis. At 1,612 miles across, it's the largest corona on Venus. Magellan radar images are combined with altimetry to create a 3-dimensional map of the surface. Simulated color and radar clinometry are used to enhance the small-scale structure of the surface features. Now, over Mitchell Crater into the trough surrounding Artemis. Then to Diana and Dali chasms. And our flight ends as we ascend for a final view of Artemis. This was America's first spacewalk in 9 years. The astronauts were attached by safety tethers to slide wires attached just inside the payload bay. They wore a new design in spacesuits, also called extravehicular mobility units. A portable life support system was worn on the back, finally eliminating the need for a lifeline connected to the orbiter. Continuing their quest for reusability, the suits were not custom-built for each astronaut. Tops and bottoms of different sizes could be mixed. They were also more flexible than previous spacesuits, allowing a greater practicality and comfort for extended use in space. The crew removed tools from a storage locker in the front part of the payload bay, then moved off again. Using a cable run through a winch mounted on the bulkhead, then tied to the cradle that had held the IUS, the astronauts demonstrated they could have lowered the cradle manually had commands from on board failed. Winch operations were tested on the front bulkhead using an exogeny as a load. This was to test how many pounds the winch and line could handle, and was part of NASA's investigations into the capacities of the shuttle fleet during operation. Lastly, the tools were restowed and the astronauts re-entered the spacecraft. Perhaps the most visually spectacular mission since the Apollo missions to the Moon. Challenger's shuttle flight gave us the first live view of the orbiter in action in space. After 6 visits to the Moon, we had learned a lot about the makeup of the Moon. It also changed the way we looked at our nearest celestial neighbour. With a new focus on lunar exploration by several countries, interest has again been revived on setting up a permanent lunar base. It could also be a springboard for manned missions to Mars. It is possible that the early lunar settlers will also have to be miners, depending on the success of some researchers. They are looking for a potentially valuable product, helium-3. It could be mined using a large automated vehicle which would do most of the work of processing the rocks and soil. Helium-3 is a very rare isotope. Just 25 metric tons could provide enough energy to generate all the electricity used in the USA each year. Helium-3 is produced by fusion reactions in the Sun and carried through space by the solar wind. Earth's atmosphere shields us from the solar wind, but it's been depositing helium-3 on the Moon for more than 1 billion years. Studies indicate that the amount of radioactivity in a machine like this, generating energy from helium-3, will be 1/1,000,000th less than in nuclear systems used today. And no greenhouse gases, acid rain, or solid waste will result. The mining system proposed would not make a big mess of the lunar landscape. Once helium-3 has been boiled off, the untainted rocks and soil are returned to the surface, leaving it essentially unblemished. One of the byproducts is expected to be water. Something of great value on a very dry lunar colony. German archaeologists are celebrating a fascinating discovery which shows the communities as early as 5000 BC were plotting the movements of the sun. Archaeologists from Halle University and regional archaeological authorities, along with the group of around 30 students from Martin Luther University, are helping to excavate the site, and they can hardly believe their luck. The archaeologists are able to date fairly precisely the origins of the observatory and cites other more famous monuments as descendants of the Gossec construction. Although there are many other so-called circular monuments throughout Europe, the site at Gossec is of incomparable historical importance. The others, though similar, are nowhere near as ancient. The most famous of them, the British tourist attraction Stonehenge, a massive 20-metre-high menhirs, is 2,000 to 3,000 years younger. Archaeologists here have certainly had their fair share of sensational finds. It is barely a year since the region's experts uncovered an object of similar value and function, the Nebra dial, which was also used to mark the sun's path throughout the changing seasons. They are sure that there is a close link between the two discoveries, not only because the dial was found just 25 kilometers away. There seems to be a definite connection, as the markings on the dial are those which appear Gossec construction 3,000 years earlier. The markings are the horizontal lines on the dial which make clear the sun's winter and summer paths. The remains at Gossec were only discovered by means of aerial photographs showing traces of the circular construction on the ground. Archaeologists expect the German site to take approximately 5 years to be completely restored. If you thought travelling to the moon would be all business, then you are mistaken. On his trip, Alan Shepard took along his clubs and ball and went out for a little game of golf. Just watch that swing, see his style, and note the exclusive uniform which has to be worn at all times when playing here. His game wasn't too bad when you consider this is a 5,500-yard fairway and a par 19. So if you want to join this exclusive club, just head for the moon. Whether it's a full-scale mock-up of the shuttle used by astronauts for training or a display model of a futuristic lunar transportation system, a small group of craftsmen at NASA's Space Center has probably had a hand in its construction. For 30 years, modeling has been an integral part of engineering support for the space program. Each project, whether large or small, has its own set of challenges. The model shop typically has a number of projects going on at the same time. Here, craftsmen are assembling a model of a space station vacuum cleaner. Larger projects, like this model of a heat shield for a space payload, go through a series of trial stages before the final component is built. A low-cost wooden fiberglass mock-up helps engineers decide where to place instruments and wiring. A model of the exterior ensures that the heat shield's tiles will fit properly. These are all necessary steps that have to be taken before the final prototype is built. Most model building is still done by hand, but recently, labour-saving computer-driven machinery has taken over some of the tasks. The model shop's latest high-tech apparatus literally grows parts out of plastic with the aid of lasers and computers. These model makers have one of only a few laser stereolithography machines in the country. Engineers can come into the shop with a part they have designed, and the machine will build it by scanning laser beams into a vat of light-sensitive plastic. Minute by minute, the laser builds up layers of hardened resin. A part that might have taken a week to machine can be completed overnight. Although labour-saving devices play a vital role in modelling, it's the skill and artistic ability of the people that brings ideas to life. The model builders, helping to turn the concepts of today into the flight hardware of tomorrow. This story takes us to the edge of space. Using balloons and rockets, astronomers have successfully launched several telescopes above the distorting effects of the atmosphere. To explore deep space, NASA has had great success with robotic probes like Voyager that have observed and sent back images of the solar system. Hubble can see objects near the edge of the known universe with 10 times finer detail than they could be seen from the ground. At the heart of the observatory is an 8-foot mirror, ground to near perfection. When pointed at an object, the mirror collects light and sends it to 6 instruments. Various satellites and ground stations relay the instrument's information to the Space Telescope Science Institute in Baltimore, Maryland. Viewing screens then allow scientists to make on-the-spot observations. At the same time, a tremendous amount of data is generated and stored for further study. In order to help astronomers plan observations, the Space Telescope Institute has the largest star catalogue in the world, containing 19 million celestial objects. The catalogue was made by scanning over 1,400 photographic plates of the entire sky. The Hubble telescope allows us to see star systems and planets, but in particular, it's designed to look out into deep space and study deep space astrophysics, to look into a realm that until now, we've not been able to study well. In our lifetime, space telescopes should match the enormous discoveries made at the very beginning of astronomy. They became instant celebrities. After their return, they visited 24 countries and 27 cities in 45 days. For Bill, covering this world tour was a special highlight. Bill grew up in an era where travel by rail was everything, and landing on the moon was only a wild dream. While he's not tinkering with his train collection, Bill enjoys leafing through some very special books, each page a memory, a glimpse of history in NASA's photo album, which he helped to create. From the very beginning of the space program, NASA has been recording much of its progress through the lens of photographer Bill Taube. Taube was able training runs and missions. John Glenn made history the day he entered his Mercury capsule. Taube knew he had to provide coverage that would satisfy photo editors all over the world. And he did. During his career, he received many awards, among them Photograph of the Year for coverage of Gordon Cooper's flight in 1963. In 1969, the world watched as astronauts Armstrong, Aldrin and Collins carried out America's first mission to the moon. According to Bill, his first shots were just basic wind tunnel photographs, but he always tried to think of ways to make them more artistic. In 1958, the NACA became NASA, and Bill Taube was sent to Washington, D.C. as the agency's senior photographer. He was assigned to the original 7 astronauts, covering all aspects of their lives, not just their work. Bill captured the tension of the training exercises, the camaraderie, and the spirit of each occasion. He was also the only photographer allowed free access to closed-door meetings to capture the essence of the space program in his work. From the time NASA began in 1958 through the last Apollo flight in 1975, he photographed every significant aeronautics and space event. Bill likes to joke that he was a photographer for NASA even before the agency was formed. In the 1940s and 50s, he worked as a wind tunnel photographer with the National Advisory Committee for Aeronautics, NACA, in Langley, Virginia. After hours, Bill worked alone, setting up his bulky 8x10 camera in the cavernous tunnels. This pioneering work let the public see aeronautical research as never before.